Okay, here's our second lesson on air pressure. We have our different vocabulary to get us started. Looking at atmospheric pressure, a bar, a barometer, density, equilibrium, isobar, kinetic energy, and millibar. One of the things that we did then was a lab on investigating air pressure. With the lab on the air pressure for this experiment, pressure in a jar, we had a glass bottle set up. The glass bottle is inside a plastic jar with a rubber stopper and a plastic tube. And what we're going to be looking at here, if I can center the video a little. As we squeeze or increase the pressure inside the plastic jar, we can see that it pushes down on the green water, and when we release that, it shows the water expanding. As we squeeze, it is compressing the air inside, and when we let go, the air inside then is able to expand and press back on the water and push it back up the tube. So as the air in here gets compressed, it pushes down on the water in the tube, forcing the water down into the glass jar. When the water goes back into the glass jar, the air inside gets compressed. When we let go of the plastic jar, the pressure outside the glass bottle goes back down, allowing the air inside at higher pressure to push back on the water, forcing it up the tube and back into the lower pressure area, and that happens until the pressure in the glass bottle and the pressure outside the glass bottle are the same. Going back to our worksheet on that, with that lab, when we squeeze the bottle, the water goes down in the tube. Why does it behave that way? We decrease the volume of the jar, and that increases the air pressure. So we were looking at a little bit of Boyle's law as the pressure changes. The pressure increases on the water, forcing it to go back down the tube. That increased pressure forces the water back into the container. The air inside the glass bottle gets into a smaller volume as well, and an increase in pressure. And it causes the water to fill the space where the air is inside the glass bottle. Then when we let go of the plastic bottle, the pressure outside the glass bottle goes back down, and that's where the air can expand, push back on the water, and force it back up the tube until the pressures inside the glass bottle and outside the glass bottle are equal. One of the next things we did was read an article in class, What is Air Pressure? And it talked about how atmospheric pressure is all around us, pushing on us all the time. As we kind of take a look at the different parts of the article, it goes over measuring air pressure, talks about what a barometer is, and Torricelli and his first barometer. Then it gets into kind of a bellows system with the barometers and an altimeter. Then we get into these different think questions. With the different think questions, we can go over those. If we were driving down a mountain, what makes those interesting experiences when our ears seem to want to pop, or sometimes that's uncomfortable? When you're up in the mountains, the pressure in your inner ear is the same as the surrounding air. As you drive down the mountain, the lower elevation, there's an increase in pressure. The air pressure pushes on your eardrum, compressing the air in your inner ear, straining your eardrum. When the air flows from your throat into your inner ears, the pressure difference across your eardrum equalizes with a pop. So it kind of balances out that pressure. Okay. Question 2 there, why doesn't the air pressure crush an empty soda can on the table? The air pressure inside and outside the empty soda can are the same. So the air pushes with equal forces all over the can, inside and out. If a meteorologist says that the air pressure is getting lower, what would we expect to see happen to Torricelli's mercury barometer? The mercury level in the barometer would go down because the air is not pressing as much on the mercury. The mercury in the tube would go down. If the barometric pressure was going up, we would push down more on the mercury, and the mercury would get pushed further up the tube. If Torricelli had drilled a hole at the top of his glass barometer, holding in the mercury column, what would have happened to the barometer? The mercury would flow out the bottom because the air pressure would be pushing down on the mercury through the hole. Okay, in a similar way, if we drilled a hole in Torricelli's anerometer or barometer, we would be able to see that the hole would allow for the mercury to get pushed down. And if we were able to push down that mercury, then we would be able to see that the air pressure is everywhere. So just like that little video that I showed you there, because I put a hole inside that bottle, when I was able to take out some of the air from in there, the atmospheric pressure from in the room was able to then fill up the balloon or push against the rubber balloon, inflating the rubber balloon with the air pressure from inside the room, or the greater amount of air from inside the room. And that's what would have happened to Torricelli's barometer if he had drilled a hole in it. The air pressure would just fill that area. One of the last things that we're going to look at here is going to be Boyle's law. Boyle's law: for a fixed amount of gas kept at a fixed temperature, pressure and volume are inversely proportional. Boyle's law is the gas law, stating that pressure and a volume of gas have an inverse relationship when temperature is held constant. Okay, if we think of something like shopping and the amount of money we have, or our bank accounts, the more things we go out and buy, the lower our bank account or the amount of money we'll have is. So they're inversely proportional. If we don't shop that much, then we have more money in our pocket and more money in our bank account. So again, that's one way to think of things being inversely related. And one of the last things here. Okay, as we look at Boyle's law, we can kind of look at this little diagram here where we have volume, temperature, and pressure. Okay, and if we keep temperature constant, if volume increases, pressure will decrease. And then if we have a change in pressure, where we increase the pressure, the volume will then decrease. So again, kind of just taking one last look there at Boyle's law.